is the 5 years average?
Okay, so we mentioned that there were two types of error. The first of which is random, and there's not a lot that we can do about that. Random errors tend to be less concerning to us than the other type of error, because they come and they go, there's no pattern to them, which is why it's good. And so if this is in some kind of mathematical trend, you might be able to spot that it's random and remove that data point from your pool of collected data. Or, over the course of time, random numbers basically go away. If you just add them, they sum to zero over the course of time. So, less of a concern to us. And then we have systematic errors, and systematic errors arise for a number of reasons. You didn't design your experiment correctly. You didn't use the correct tool. You didn't calibrate the tool that you had used. So if we are doing some kind of experiment where we make some stuff and then we weigh it, and then we make some stuff again and we weigh it and we see if we can reproduce that information, and we're using a scale that has not been set to zero, then it will never read the correct number. And now, right, so let's say, every day you yourself are tracking your own weight, and you stand on your bathroom scale, but your bathroom scale isn't set to zero. It's set to 10 pounds. As scientists, we don't use pounds because we're metric, but it's set to 10 pounds because you haven't zeroed it. Well, the increments between your weight gain or weight loss are probably true, but the absolute value of your study is shifted positively 10 pounds. Okay, so depends what you're looking at. Are you looking at the difference between the numbers, or are you looking at the absolute number? If you're looking at the number, your data's garbage. But if you're looking at the gaps between the numbers, how many pounds did I lose over the course of 2 months? You can probably still get away with it. Okay, so it depends. Sampling errors. If we go into the lab and we make copper sulfate, you may have seen copper sulfate. It makes these big, beautiful, deep, dark blue crystals. And they're kind of lozenge shaped, they're kind of prismatic shape. Okay, so you have a big plate of blue crystals and then some kind of brown sludge on the end. And your professor asks you, hey, send a sample of your copper sulfate out to see that we can analyze its purity. Got a big plate of blue crystals and a little brown smudge. Do you get your spatula and you scrape up that smudge and you put it in the tube and send that out to be tested? No, because it's clearly not part of your sample. And this is a huge part when it comes to those. If the topic that we're talking about has another word in front of the word science, then it's probably not a real science. Social science, medical science. Medical science isn't real science because it involves people. And people are unreliable. People lie. People just downright lie. If you've got the sense, if you have the sense that your company is going to remove your insurance, health insurance from you because you're a smoker, and your doctor says to you, how many packs a day do you smoke? Oh, no, doctor, I don't smoke. People lie, and then you find, oh, he died of lung cancer. Oh, strange that these non-smokers are dying of lung cancer. I wonder what that was. Well, the guy just lied on his on his questionnaire. Does smoking cause cancer? Not really a topic for this class, but it is a topic for another class. The answer is no. Doesn't cause, but it correlates to cancer. The more you smoke, the more likely the cancer event becomes. The less you smoke, the less likely that event becomes. But there are people who have never smoked that get lung cancer. And there are people who smoke a lot all their life and don't. So not a cause, but a correlation. If we mapped a population one way or the other, we'd be able to see the trend. And undersampling, we've got a couple of things here that we're going to demonstrate this morning. People are, and the nicest possible word I can use is unreliable. Other words that would fit here: liars, stupid, lots of other less nice words go here, but people are just plain unreliable. And the legal system in this country hasn't quite got around to it yet, because we still think that eyewitness testimony will put you in jail. Eyewitness testimony is like the least reliable of all evidence. There's a really good YouTube video. I have to track it down. If I can find it, I'll put it on Blackboard. It's just a man talking to the camera, and while he's talking, he's not talking. There are people playing basketball around him, and they're moving in a circle. And they say, "Try and follow the ball." You seen this one yet? Okay. So all you have to do is people moving around in a jumble, and they're bouncing a basketball between them, and the directions are: look at the basketball, follow the basketball. Okay. Should I tell you what happens? Those of you who've seen it, should I tell you what happens, or should I just post it and then see? I think I should just post it, because it's a surprise. After you watch and you think that you've done what the video asks, it then asks a follow-up question, and you go, what? Yeah. Because brains are really good and really powerful and can do a couple of things at a time, but they're really only good at doing really like one thing at a time, and then not so good. So I have a piece of paper here. It's written in English, and all I'm asking you to do is count. We can do that, right?
Yes.
Okay. So here's a quick statement. I'm going to hold it up so that the people at home can watch and can read. I would like you to count the number of times that the letter F appears in this statement. And the statement is: finished files are the result of years of scientific study combined with the experience of years. Just count the number of times the letter F appears in that statement. Okay, everybody can read that. Finished files are the result of years of scientific study combined with the experience of years. Okay, everybody got a number? Who thinks that the number of F's in that statement was 0? Raise your hand. Who thinks that there was 1 F in that statement? Who thinks that there were 2? Who thinks that there were 3? All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Who thinks there were 4? 1, 2, 3, 4, 5, 6, 7, 8. Who thinks there were 5? One person. Who thinks there were 6? 1, 2, 3, 4. Who thinks there was 7? Who thinks there were 8? Who thinks there were 9? Okay. Ladies and gentlemen, we have a distribution. Here's my follow-up question. How many correct answers to that question were there? Yeah, there's 1 correct answer to that task. And yet we have 4 answers. If we're playing Who Wants to Be a Millionaire and you don't know the answer to this question and we poll the audience, which answer do you go with? You go with that one because these people can't be wrong. There's an old statement that when everybody agrees with you, you know you must be wrong. Would it surprise you that the letter F occurs 6 times in that statement? 6 times. Okay. How are you feeling? Not so smart. Here's the deal. Language is like that. It's a specific psychological test because as humans have evolved and your control and mastery of language succeeds, you know what we do? We don't read the little words. Human brains, when they scan text, don't read the little words because it's called prejudice. Over the course of time, you have told yourself the little words don't matter. The ifs, the ands, the ofs, the its, they're not the noun, they're not the verb, they don't count. So your brain scans this and cannot see them. Apart from doing this job, I run a company and we write scientific literature for other people. And the only way to proofread anything at all, especially if it's in your content area and you're really confident in the material, the only way to proofread for spelling mistakes is to read backwards. You start here and you read the words backwards. Only then will you slow your brain down enough to be able to spot the spelling mistakes. If you read them forward, your brain is just going to skip. It's going to see part of the word and automatically jump to the conclusion that that's what the word means. And spell check can't do it 100% of the time because some words look like other words and spell check doesn't know what your meaning was. So, that's why asking people is a problem. We don't exactly have a solution, but we have a first line of defense. Yesterday, when I was teaching I'll do one more. Yesterday, when I was teaching the afternoon class, Miss Joyce came in and she said that if you want anything, you have to ask. Just go ahead and ask explicitly, because she's not a mind reader. And then she pointed at me and said, and he's not a mind reader either. And I had to stop her right then and there on the spot and said, oof, I can prove right now. And I got out my deck of cards and I proved that she's wrong. Okay. And it all goes, it's all here. It's all on this line right here. Deck of cards. You have to do it to the camera. 1, 2, 3, 4, 5, 6. I'm going to take 6 cards from the top of the pack. 1, 2, 3, 4, 5, 6. Now, you go going to need to pick a card. Is that 6? 1, 2, 3, 4, 5, 6. You're going to need to pick a card. Don't say it. Don't write it down. Just think it. Don't think it out loud. Think a card. Think of a card. Pick that card. Okay? Now, while you've got that card in your mind, think about its shape. They're all the same shape. Think about its color. 2 different types of color. Think about its value. They're all the same value. And then think about its picture. And think and concentrate just on that particular card. Okay? Because I'm going to figure out which card it is that you picked. 5, 6. Now, of course, the first rule of magic is, if you know how the trick is done, what do? We keep our mouth shut. The card that you picked is that one. I'm taking it out. I have removed your card. I have removed your card. I have removed your card. Correct? I've removed the card that you were thinking about. Now, this plays in, true, right? This plays into the fact, because people are so stupid, they want to be fooled. We pay billions of dollars to go to movies and watch Tom Cruise dismantle nuclear weapons and believe it for a minute, right? And, or worse, you know, hobbits and stuff. We want to be fooled. We pay big entertainment money for not using the rational part of our brain. Can't trust people. Don't trust people. And if you know how I did that trick, it's kind of a simple trick. Don't tell. Okay. So our line of defense here, because what we just did, like, remember paradigms? Paradigms are the most acceptable current answer. It was wrong. It was nowhere even close. The paradigm in the room was like way off. We have a line of defense, and it's a fabulous word. It's called falsifiability. Falsifiability tells us that giving more information that backs up a theory does not validate that theory. We had 17, really? 17 people think that the number of F's in that statement was 3. If another 5 people said, oh yeah, that was 3, the answer would still be wrong. What I need is the piece of evidence that says 3 is the wrong answer. Now, if anybody in the room is still saying, nope, 3, that's my answer and I'm sticking to it, you may have a successful career in politics ahead, because that's what politicians do. They take a stance, and then when faced with new, overwhelming evidence, they say, no, I'm sticking to my guns, and everybody at home goes, oh, he's a strong leader. She's a strong leader. She doesn't flip-flop. You change your mind in politics, you might as well just pack up your bags and, you know, move out of your office. changing your mind in science is an everyday occurrence because it's the smart thing to do. It is not the normal human thing to do because we have dumb things like pride and ego and hubris that says, oh no, don't let them see that I was wrong. No, embrace it. You were wrong. Don't matter, get over it. It seriously doesn't matter. It only matters if after you're proven that you're wrong, you still continue to be wrong. At which point you start to annoy us. So falsifiability says you cannot prove a theory correct no matter how much additional supporting evidence you have. You can only prove theories wrong.
When you say theory, do you mean hypothesis or like theory?
So a hypothesis is a theory that has yet to be fully formed. Hypotheses are theories without any kind of fact-based evidence in them. Like, I think the moon is made out of cheese. That's a theory. You just got to prove me wrong. Well, Neil Armstrong stood on the part that he stood on wasn't made of cheese. So, you know, at least I'm not being a jerk about it. I've at least ruled out that the part that, what did they land, Sea of Tranquility? The part that they landed on isn't made out of cheese, but the rest of it might be made out of cheese. We're just going to have to lunar rove the whole thing. So a hypothesis is an idea that we haven't got any facts for yet. But you know, this comes with evidence, and the more evidence that you pump into it just makes it feel more confident. It doesn't make it right. And as scientists, we don't talk about truth. We talk about being correct or incorrect. So you cannot prove a theory correct with additional supporting evidence, but you can prove any theory, even the big ones, incorrect with just one piece of evidence to the contrary. Okay, so we hinted at on Monday that if you don't bring evidence to your argument, then I don't really need to entertain your argument. And what we didn't talk about is sciences have suffixes. Is that Greek or Latin? I don't know. Ologies, ographies, ometries in them. And then, so we've got astronomy, which is where you look at the stars and you figure out their movements and the physics behind it. And then there's this other thing called astrology that sounds like it might be a science, but is pure entertainment. So, who's a Capricorn? Okay. How did you feel yesterday? Tell me about yesterday. So nothing really apocalyptic, no big revelations about yesterday. Capricorn?
Yes.
How was yesterday?
Stressful. Very stressful. Had a long day.
Okay. How did you handle that long day?
I took it.
Okay. So you accepted it. Who's the
Yeah.
other Capricorn? How was your day?
I was happy.
Ooh, that's not going to do. That will not do. Because yesterday's horoscope for Capricorn, and remember, Doesn't matter if you all agree with it. As soon as the first person says, no, that's not true, it goes away. It just disappears in a puff of logic. Yesterday, Capricorn, and this came from a
Boston American Statesman.
some notable publication, because there's a Ziggy on the back. Capricorn, you're in a rebellious mood and feel strangely restless until you do something, as the French say, shock the bourgeoisie. You should know that your behavior will be extremely attractive to a Leo. Okay, now, were you rebellious yesterday? No. Did you shock the bourgeoisie? No. Therefore, what can we do to your horoscope? Dismiss it. It's gone. Does not pass the test. Now, if I'd have had 10 Capricorns in here, and 9 of them went, you know what? I shocked the bourgeoisie yesterday. Go, wow, there's a correlation there. But there's no proof to it, because there's only 9 of you did it, and 1 of you didn't. Maybe they're on the cusp. Okay. Falsifiability. You cannot prove something right. Stop trying to prove stuff right. Stop trying to say, well, I have a theory, and I'm going to go back and find as much supporting evidence for my theory as I can. Because that's not what we do. We start with the observation and we try to make sense of it, and if it doesn't come out the way that we had planned, we don't care. Because it still makes a theory of some description. It's not the one that we had originally thought of. Okay. You know how horoscopes work, right? I had to have this explained to me a little while ago. A couple of years ago, somebody pointed this out. It's actually Pendulette pointed it out. He's a magician. I'm not a big magic guy. I only know 2 tricks, and that's one of them. But Pendulette is a magician. And again, another atheist. What am I doing? First 2 days on record, spouting atheism. But he said, here's how horoscopes work. You pay somebody a compliment, and then you take it back. Like, you're a really modern girl. You've got very, very modern theories about the world, but you like the traditional rule as well, don't you? And you're very active. You like to get out and do fun stuff, but there's times you want to stay home and watch Netflix. You pay somebody a compliment, and then you take it back, and they go, that's amazing. I'm a Pisces as well. You're a Pisces?
No.
Okay, so that in a nutshell is the scientific method. Chemistry is the scientific study of matter. Now we have to talk about the matter part, and this is where facts start to emerge. So again, matter is anything, I'm going to get new markers, that has mass. Mass and weight are different, but they're interconvertible. There is a difference, there's a textbook difference between mass and weight, but if you're reading mass and in your head you say weight, you're probably okay, and we'll explain why in just a second. Our occupied space, and therefore has dimension, can be measured. And we're going to talk about those dimensions today. I checked Blackboard just before it came out, and it looks like almost everybody managed to get that first quiz under the belt. Thank you for doing that. We're going to make that a routine. Pretty much there'll be 2 quizzes pretty much every week. Okay. We'll come back to mass. We'll talk about it in a minute. So some of our measurements, so we're going to measure matter and explain its existence. And the measurements that we make can be fundamental or they can be derived. Fundamental measurements are things like time. Time cannot be subdivided down into something else. It exists in its own right. It is given symbol. Oy, I need new pens. Lowercase t. We have two t's that we are going to use in chemistry. The uppercase T is for temperature. The lowercase t is for time. And it is measured in seconds. Now there's a thing called SI, the Standards Institute. And they determine, and we all agree, that these are the units that we're going to use to describe different forms of matter. And you know, time exists outside of that because it's another thing. It's a thing in its own right. We use seconds, and we only use seconds because we don't use minutes. We don't use hours, and we don't use days, we don't use months. Because they're not metric. There are not 10 seconds in a minute, and there are not 10 minutes in an hour, and there are not 10 hours or 1,000 hours. That would work. If there were 1,000 seconds in a minute, and 1,000 minutes in an hour, and 1,000 hours in a day, that would work for us. But there aren't. There's 12s and 60s, and so that's not metric. But this one is. Seconds are metric. You can have metrics be, seconds be in the thousands, or we can now subdivide, and you will have learned this in school at some point, but we do it slightly differently than the way that they teach in school. So the root unit is the second. A millisecond, 2 L's, is a lowercase m, lowercase s, and that is 1 second divided by 1,000. We're going to be off camera. Which is the same as 0.001 seconds. Now, here's what you know, but you're not doing. You guys know that there's a 0 there in front of the decimal, right? Mm-hmm. How many of you didn't write it down? Yeah. Get into the habit of writing that 0 down, because it's there for a purpose. When we convert this into scientific notation, when my first figure of significance, this is my first significant figure, is below the decimal point, what I'm going to do is count the number of zeros. So this ends up being 1 times 10 to the -3 seconds. And if you don't put that lead 0 there, and you just say 0.001, because you just saved yourself like 12 milliseconds by saying that instead of 0.001, then you don't read it and scan it and know what the correct scientific notation is. Okay. Now, at high school, they tell you that that number can go up and down and be any number that you want it to be. And in some sense, that's true, but it's not the way that we break the units down. Because less than that is a microsecond. And micro is given the symbol mu. It's like a U, only with the long tail that leads into it. It's the Greek lowercase form of mu. And that is 1 second divided by 1 million. We're going to move in increments of thousands. So a millisecond describes 1,000th of a second. And we talk about milliseconds until they're in the thousands, and then we start talking about seconds. And if I have less than a millisecond, I might talk about 1/10 of a millisecond or 100th of a millisecond. But when I start talking about 1,000th of a millisecond, it's time for me to start talking about microseconds instead. We make the jump between the units. Okay? So this is 0.0000, I'm going to count 1, 2, 3, 4, 5, 6 seconds, which is 1 times 10 to the negative 6. So a microsecond is 1,000th of a millisecond. A millisecond is 1,000th of a second. One step down, you know what 1,000th of a microsecond is? That's a nanosecond, which is a lowercase n. That's a second divided by 1,000,000,000. So that's 9 zeros in the billion here, because a billion is 1,000 million. There was a time when the English definition of what a billion is and the American definition of what a billion is were different. That an English billion was 1,000,000 million, and an American billion was 1,000 million. And so if anybody offered you $1 billion or £1 billion, the answer was clear which one to take. .00. So here's why we use scientific notation, because I've already lost track of how many zeros I need. I'm just writing, and now I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, how many digits do you have on your calculator? Some of them have 8. If you have 8 digits on your calculator, you are now out of luck. You cannot write this quantity down. Okay. If you have 10 digits, you cannot go any smaller than this. So what if I told you it was 1.1 second divided by 1,000,000,000? You wouldn't be able to write that in on your calculator, which is why we have the scientific notation in the first place. It condenses the form. Okay, the exponent here, the number that we're multiplying by, is negative, and that tells us that we are below 0. Okay, we are not below 0, but we're below the decimal. Below 0 would be negative, and that's not what we are. Now, time really doesn't seem to have any limit to how small we can go. there's going to be a time, there's going to be other things that we describe where we'll talk about mass. We'll say we just simply can't measure any smaller than that. Lower than nano is pico, which is 1 times 10 to the negative 12 seconds. I've now run out of space, I can't write that down. But it's 1,000th of a nanosecond. Anybody know what comes under pico? Now that I've written it down, femtosecond, which is 1 times 10 to the negative 15. We don't even have, I don't know that we have a word for that on the scale upwards, because this is 1,000th and a millionth, and then a billionth, and a trillionth. You say quadrillion, is that really a word? So 1 quadrillionth of a second. We have pulsed lasers that operate this quickly, and we can, like strobe flash, atoms bumping into each other at that speed. So this is how low we can go. Notice that we haven't gone upwards. We haven't talked about what 1,000 seconds would be called. That would be called a kilosecond. And nobody has been brave enough to say those words out loud because it sounds wrong. So we talk about seconds just as the bulk number. We don't talk about megaseconds or kiloseconds or whatever, just seconds. Oh, so we're still on fundamentals. Let's talk about what else we've got. Distance.
That is so fundamental to mention.
So, going to do 4 fundamentals. They are time, temperature, distance, and mass. Distance is measured by the meter. Anybody know what a meter? We have a meter stick, right? These better not be in inches. That's a meter. Do you know what its derivation is, this distance? Dressmaking. You're pulling cloth off of, you know, they put cloth on rolls. You're pulling cloth off the roll. You do this action. You have the roll up here and you pull it to your nose. That's a meter. Thereabouts. Okay. Do you know what a yard is? Exactly the same thing. Only the King of England was shorter than the King of France. And that was the role model that they measured what a yard was and what a meter is. It's that much and turn your head. So that much is a yard, that much is a meter. Seriously. Meters. So if you can talk in yards, you can talk in meters. And yeah, we play football by the yards. We used to play rugby by the yards. Now we play by the meter. We can change. All the Olympic stuff's metric. There's nothing non-metric in the Olympics. And we adjusted, right? So this one, we've got numbers that can go up and numbers that can come down. So our core value right here is the meter. If I divide that meter into 1,000, guess what I get? I should get a millimeter, because I have already written it out. So we use the same process each time. And a millimeter would be 1 meter divided by 1,000, which is 0.001 meters. Don't forget to put that 0 in, because it tells us 1 times 10 to the negative 3 meters. Okay, if I multiply up by 1,000, yeah, I get a kilometer or kilometer. And now that prefix right here is a capital. When you incrementally make them smaller by the thousands, those numbers are lowercase. When we make them larger by the thousand, that number goes up and becomes uppercase. So that is 1 meter times 1,000, which is 1,000 meters, which is 1 times 10 to the 3. When the number gets bigger, the exponent up there is positive. When the number gets smaller, the exponent there gets empty. There's not a lot that we're going to do in chemistry that does kilometers. We usually work on very, very small scales. So again, we would divide by 1,000, and we would go to micrometers. And then we, oh, that says 100. We would divide by 1,000 and get a nanometer. And this is 1 times 10 to the negative 6. And the nanometer is 1 times 10 to the negative 9. This is starting to be the scale now about the size of atoms. Atoms are a couple of hundred, we're going to get to picometers, there are a couple of hundred picometers in diameter. So we can either call them fractions of nanometers or multiples of picometers. So somewhere here in the middle is the size of an atom. And there's a made-up unit, it's called the angstrom. It's in the book, it's probably on a quiz question somewhere. We're not going to use it, but here, where the size of the atom is, at 1 times 10 to the negative 10 meters, a certain branch of physics that only looks at X-ray pictures of atoms, called crystallography, have decided to give that unit a non-standard unit because it's not divisible by 3, right? All of our standards, millimeter, micrometer, nanometer, are by 3, and this one isn't. That's called an angstrom. Okay? Telling you it's there, it exists, that's its number. We're not going to use it. I'm not going to use it for the same reason that I'm not going to use centimeters. Instead of saying 1 centimeter, I'm going to say 10 millimeters. Because millimeters fall into this case where everybody does the same thing. You either multiply by 1,000 or you divide by 1,000. And you keep your units consistent amongst everything. Okay? So we have temperature, we have distance, we have time, and what was the other one? Mass. Do mass on Friday. I don't have enough time to talk about mass versus weight. I don't have enough time to talk about the temperature scales. Don't really have any announcements for you, anything that's a concern?
You said once per class we had a free lecture quiz, but 1.2 said it was due Wednesday.
So 1.2 is the online quiz for the content that's in chapter 1. 1.1 was the little pre-lecture quiz. So the next pre-lecture quiz is called 2.1, and it's probably going to close, because Monday isn't a day, it's probably going to close Tuesday at midnight. Tuesday night.
Tuesday next week?
Yeah.
Okay.
No, Tuesday this week.
Was it in 1.2 is before class on Friday?
No, it's going to run. It probably the end of next week.
September.
Yeah.
Okay.
So the regular chapter quizzes run for a couple of weeks, so that you can do the material, we can discuss it, you can do the homework, and then you can tackle the quiz. Take a breath, and then attempt it again. There's always multiple attempts on these things. So the regular chapter quizzes might have 10, 15 questions in them. Take your time, or don't take your time with them. You're going to have time.
So no quizzes before next class?
Now, the Friday's class? No.
So there's
For next week, we're going to start chapter 2. There is a pre-lecture quiz for chapter 2 that must be done before the first lecture of next week, which will be Wednesday, because we don't meet on Monday.
Is that 1.2 or
It will be
2.1?
2.1.
So there's no quiz for Friday.
The next thing due is on September 7th.
So yeah, they're all listed there, and when you look at the quiz on Blackboard, it will tell you that the approved questions that I wanted to do have these numbers, so there's a number that are on Blackboard. It's just learn some definitions so that when I say it, you don't know what to say. I just want you to know a little tiny bit.
Okay, that's not bad.
So, okay. Why did you like? Why is it? I don't know that you know. Do you know why you're